In this screencast, we're going to review algebraic expressions. So if you take a look at the center circle or oval, we're going to define what an expression is. So an expression includes the following things. It includes numbers, symbols, and operation signs. So I'm going to write that down. So it includes numbers, symbols, and operation signs. Okay, so remember numbers obviously would be like 1, 2, 3. Symbols could be letters such as X or Y. Could also be your parentheses. Operation signs would be your addition, subtraction, multiplication, and division. And basically what that does is it groups together things that have the same value of something. So if you take a look at the pieces that are extending off of the idea of expressions or off of our definition for expressions, let's start with the word term. So the word term, and we'll write an example down for this part. So with our example, let's do 5x plus 2 minus 7y. So if you take a look at this example, our terms are a single number or variable separated by addition or subtraction. So terms are the part of the expression separated by addition or subtraction. So if you take a look at our example, we have 1, 2, 3 terms because they are separated by an addition or a subtraction sign. Moving on to the idea of a constant. A constant is going to be any rational number without a variable. So for example, a constant could be 5. It could be negative 1/2. It could be 0.3. And if we take a look at our example, 2 is our only constant because it does not have a variable attached to it. It's by itself, it's constant, it never changes. Next is a variable. So a variable is a letter that represents a number. That's the whole point of an algebraic expression, is that it has a variable. So if we take a look at our example, our variables would be the letter X and the letter Y. They are in place of a number which we don't know yet. And then the final definition is a coefficient, and that is the number attached to the variable using multiplication. So if we take a look, 5 would be a coefficient because it's 5 times x, and 7 would be a coefficient because it's attached to y. Let's go ahead and take a look at a couple examples where we are going to practice writing expressions. So this is on the back of your note sheet. So if you take a look at number 1, it says Billy knows that the weight of each baseball is 5.25 ounces and that each softball weighs 6.5 ounces. Write an expression to find the total weight of B baseballs and S softballs. So I don't know how many baseballs or softballs Billy is weighing. I do know that it's 5.25 ounces per baseball. And I know that it is 6.5 ounces per softball. So if we think about the first piece, this 5.25 ounces per baseball, I know that if I take 5.25 and I multiply it by the amount of baseballs, that's going to give me the total weight for the baseballs. I also know that since it's 6.5 ounces per, this means multiplication, per softball, we can also do 6.5 times S for our softballs. If we're finding total weight, we're going to add those together or put an addition sign in the middle. So now what can I do? I can simplify each piece. So I'm going to take 5.25 times B and rewrite that as 5.25B because a letter next to a number means multiplication. And I'm going to multiply 6.5 times S and get 6.5S. Again, bringing down my addition sign. This would be my final answer because I have two different variables, so I cannot combine or simplify anymore. Let's take a look at the second example. This says that Mark is loading a crate that weighs 22.5 pounds and B boxes that each weigh 11.25 pounds onto a truck. We're asked to write an expression to find the total amount of weight on the truck. So again, we know that he loaded a crate that weighed 22.5 pounds. Okay, so we know that's already sitting on the back of the truck. Okay, so that's on the truck. Then he's also adding some amount of boxes that each weigh 11.25 pounds. So if I take this is by itself, right? There's nothing affecting that. It's the weight of the crate. So the crate weighed 22.5 pounds, but I can combine the 11.25 times B, which would get me 11.25 B for boxes because I don't know how many boxes there are yet. To find the total amount, I'm going to add those two things together or put an addition sign in there. I can't actually add them because if you look at 22.5, there's no B behind the 22.5. So these are not like terms. So my final answer or my final expression will be 22.5 plus 11.25B. And I can't solve until I figure out what B is, so how many boxes there are. Final example number 3, we're going to have a two-part to this. So Amanda bought G gallons of paint for $16.55 per gallon and T pints of paint thinner for $5.97 per pint. Write an expression to represent the total amount that Amanda spent. So again, we see this word per, which tells us we're multiplying. So we're doing $16.55 times G cans or G gallons, because we don't know what that is. And we know we bought T pints of paint thinner, and that's also, we see that word per, $5.97 per pint. So again, we're multiplying there. To find the total, we would add them together. So now we're going to simplify. So we get 16.55 G plus 5.97 T. This would be our expression. And now what they're asking us to do, or they're telling us, it says, if Amanda bought 8 gallons of paint and 3 pints of paint thinner, how much did she spend? So if we're looking for how much did she spend, we're going to rewrite our expression. So 16.55 G plus 5.97 T. And what we're going to do now is we're going to take this information that we're given, this 8 gallons of paint and 3 pints of paint thinner, and we're going to substitute or replace the letters. So 8 gallons replaces G, so this becomes 16.55 times 8 plus 3 pints replaces T, 5.97 times 3. We're going to go ahead and multiply first, because according to order of operations, we multiply first, and then we add our final answers together. So 16.55 times 8 equals $132.40 plus 5.97 or $5.97 times 3 is $17.91. We're going to add those together, and we will get a total of $150.31. So Amanda spent $150.31.